Hi there and welcome to lesson 6 of our C5 How Much Quantitative Chemistry topic. Today we're going to be looking at monitoring reactions and how we can actually follow what's happening during a reaction. Anyway, I'll see you at the end. So our objectives for today's lesson are as follows. So by the end of this lesson on monitoring reactions, you should know and understand how a reaction is monitored in order to calculate the endpoint and any rates of reaction that we need to find out. Now, a lot of reactions that you may do may involve the release of a gas product, and it's quite simple to monitor the amount of gas that's given off. Now, there are several methods that you can use. All of them have valid reasons to select them, and all of them have valid reasons not to. Now, the first one we'll look at is this one here. Now, what favours this one is it is very, very easy to set up. That you've got a conical flask with your reaction happening in. You've got a very small amount of space here with the bung and delivery tube going into a vessel with water in, and then you can monitor the gas being given off as it will displace the water in here. Now, the measuring cylinder, as you've probably seen in the lab, is not the most accurate way of actually measuring a volume, and also it is very difficult to get the water to go right up to the very top when you're actually filling this up. Now, in comparison to that one, this is a very similar setup. Again, we've got the conical flask here with the reaction happening, and then a delivery tube going into a gas syringe. Now, before you set this up, the gas syringe needs to be fully pressed in before you push it into here. Again, you might find that this is slightly not quite at zero, but the accuracy you'll get and the precision you'll get on the readings will be a lot better. Now, the third and final method is similar to the first one. Instead of using a measuring cylinder, you use a burette. Now, the burettes only go up to 50 centimetre cubed, although it will be easier to get this into the vessel of water. And again, we've got our conical flask which goes in and round. Now, with the three reactions or three methods that we have seen, there is basically the same step that we need to go through with each. The first is to measure out the reactants. Now, once you've done this, you can add the reactants together and start the timer. Now, what you need to be careful with this is making sure that you get the bung onto the conical flask where you're actually carrying out the reaction. Now, the third step is to measure and record the volume of gas that's produced. Now, you'll need to do this at regular time intervals, such as every 30 seconds, every minute, and then you stop once you've had a couple of readings where it's no longer being produced, so you get that levelling out of the volume of gas being produced. Now, monitoring the reactants will give you the same information that you get from monitoring the products. It's just reversed. Now, if we look at how we can do this, we can see this equipment here. Now, again, we've got the conical flask, and this time, instead of being bunged, it's got cotton wool in. Now, here you've got the reactants in here, and then you've got the bubbles being given off as a gas. Now, because the gas is given off and it comes out of the top here, it means that the mass of the reactants is decreasing because of that lost gas. So that gas that's being given off would give you a volume as it did on the previous ones, but this is now the mass will be decreasing. So let's have a look at the steps that we need to take with this one. The first step is to weigh an empty conical flask. Then we can measure the reactants, and then we can calculate the total mass of the reactants and the flask. Then our fourth step is to add the reactants together into the flask and start the stopwatch. Then it's the same as before. is to read and record the mass at regular time intervals. So again, it could be 5 seconds, 30 seconds, a minute, or whatever it is you decide. Now you can often identify when the end of a reaction is by monitoring either the reactants or the products. If you're monitoring the reactants, then all the reactant will disappear. Whereas if you're monitoring the product, then the product will stop being formed. Now when you have a reaction that is a 1-to-1 ratio, so if you've got 1x plus 1y, whichever has the lowest moles will be the limiting factor. So if we produce 1 mole of Z at the end, this will be proportional to the amount of the product that is, or the reactant that is lost. Now we can actually monitor what happens during a reaction. Now during a reaction you normally get a curve that happens like this. So as the time increases, the volume of gas will also increase. But what you may also notice is these points here. So if we highlight, let's do that in a different colour. So if we highlight this section here, and then this section here, and then this bit at the top. Now at this point here, where we've got the steepest part of the graph, this is where the reaction is the fastest. Now as we progress up the graph, so this section here, we can see the curve is less steep, and this is where the reaction slows down. Now right at the very end, when perhaps the graph flattens out here, this is where the reaction becomes to an end, and that's because we've got horizontal, meaning that there is no more gas being produced here, meaning that the reaction has finished. Now what we're going to do now is have a look at two reactions. Now the first one that we're going to draw, we'll do this in green. Okay, now you can see, like it was in the previous section, we've got the fastest part of the graph of the reaction, then it starts to slow down until it comes to a stop. Now if we look at a second reaction that we'll do in orange, okay, we can draw the reaction here, and again you can see it starts off fast. In fact, it starts off faster, and then it slows down, and then it comes to a stop. Now the difference between these two graphs is the amount of one of the reactants. Now if we look at the green line first of all, this has a reactant which has a concentration of 1 mole, or there's 1 mole in terms of the amount. Now this means that we produce this amount of gas. Now if we look at the second reaction in the orange, this has 2 moles, and it should be double the amount of gas. So you can see here that if you double the reactants, you double the amount of products that are produced. Now you can see where you've got the fastest parts, where you've got the slowing down, and then where you've got the reaction coming to an end. Okay, so we've been looking today at monitoring reactions. We have looked at how we can monitor the products of a reaction using various bits of equipment, especially when there is a gas involved. We've looked at monitoring the reactants in there, and we've also looked at how we can analyse the results that we get from it. Anyway, I hope you've enjoyed this, and I will see you next time. Bye bye.